Hello everyone, and welcome to today's video on measurement, precision, and accuracy. So when we talk about our measurements, we talk about them in terms of accuracy and precision. So accuracy is how close a number is to the actual or correct value. So how close your measurement is to the known value for that measurement. And precision is how close your values are to one another or how consistent your results are. So sometimes we'll take a measurement more than once, and if your measurement or your data collected are close to each other, we can say that's precise and we have a repeatable experiment. But if you take your measurements multiple times and the data is scattered, and the measurements are not close to one another, then we would say that we do not have precise data. So a really common way to look at the accuracy and precision of a set of data, or just an example, is using a target. So the goal, let's say we're shooting arrows at a target, is to get a bullseye to be in the center. That would be our known value. So target number 1, we have low accuracy because our arrows are not near the bullseye, the goal, and we have low precision. Those dots are not close to one another. If we look at target number 2, we still have low accuracy. We're not near the bullseye. We're not near the known or wanted value, but we actually have high precision because those dots are close to one another. They're consistent. Number 3, we have high accuracy. Those dots are around the bullseye, right? Those arrows made it close, but we have low precision. We were not very consistent in shooting the arrow. They don't end all bunched together. And then finally, the 4th target. This is the goal: high accuracy and high precision. You're close to the bullseye, and all of the data points are close to one another. They're consistent. Our arrows landed, it looks like, even on top of each other. So the precision of your measurement will actually depend on the instrument that you're using. So for example, we have beakers written in increments of 10 milliliters, 25, excuse me, and 50 milliliters. So depending on the increments, the precision changes. So let's say, for example, we wanted to fill our beakers with 110 milliliters of water. On the beaker marked off in 50 milliliter increments, can't be very precise. We see 100, we see 150. So let's say 110 is right about there. That's not very precise. If I do that multiple times, I find it hard to believe that I'll be in the exact same spot every time I fill to 110. With this middle beaker, we get a little closer. We have 100, we have 125. So I'll say 110 is right about there, right? You're a little more precise. It would be more consistent to use this beaker. But the most consistent is this beaker on the far left. If you wanted 110 milliliters, you fill right to that 110 milliliter line. That's precise, that's repeatable, and that's consistent. So in physics class, we use sig figs in terms of measuring. So in terms of calculating, it's a little bit different than in chem last year, but in measuring, we use sig figs to keep track of the precision of instruments. And then we use that precision in our following calculations. So when we measure, this is huge. In your notes, maybe put a star by this. We read all digits possible and then estimate to one more digit. So the last digit, of course, will differ from person to person because it's an estimate. So an example of reading to one more digit with proper sig figs is this water in a graduated cylinder. So recall that when you bake or when you are in science class, when you measure the volume of a liquid, you read from the bottom of the meniscus. You want to be at eye level with the bottom of the meniscus, the bottom of that dip. So first, we read to the marks on the measurement. So that looks to me, right, this is everyone's place, 56. But in order to have proper sig figs in precision, we estimate to 1 point more. So 56, we need to go then to the 10th place. And to me, I'm convinced that's on 56, but I cannot leave this as 56. I need to write 56.0. So I had to estimate this tens place. Okay. So we have two rulers and they have different values of precision, right? The top ruler is marked off every centimeter, while the bottom ruler every millimeter. So let's see what will give us a more precise reading of that red line. So reading the top ruler, I read the 3 right off of the ruler, and then I estimate one more place. So I'm going to say that's, just looking at the top ruler, I'm going to estimate 3.4 centimeters, right? So that 0.4 I estimated. Moving down to the bottom, we read what the marks on the ruler give us. So it gives us, in that case, 3. And then we have the millimeters, so 3 centimeters and 4 millimeters. Oh, sorry. Or 3.4 centimeters, but we're not done. We need to estimate one more decimal place over. So that line actually, to me, doesn't look like it's on exactly 0.4. So I'm going to estimate that this line reads 3.41 centimeters. So the bottom ruler gives us a higher degree of accuracy because we have 3.41. We can go to the hundredths place rather than the tenths. And then finally, in measuring, we compare our known values to the actual values. This helps us to learn about our accuracy. And we can calculate percent error by using the following equation. Percent error equals the absolute value of the actual value minus the minus the measured value. Those are the same thing. Over the actual value times 100. So notice we are in the absolute value. So even if what happens inside the absolute value is negative, your answer is always positive.